Okay, good morning. How are we? Good. My sincerest apologies that it was due to my arrival, delayed arrival. We are starting this program half an hour late. When I took the outer ring road, because I'm traveling from my native place, there was an accident. So they were trying to clear up, and then we got stuck in the traffic. So sorry for that. Otherwise, I thought of coming last night, but I got held up for some other reasons. So what I'll do is I will just give a brief introduction about myself and a brief introduction about the course and what it entails and what you would achieve by the end of 2 weeks that you attend here. And then joining the dots, why different people are coming on board, which Professor Narasimha has already explained, but I will also touch upon a few things. And then see where from here, right? And then we'll talk about some important definitions that underpin critical minerals, which are global in nature, and each country has got their own definition of critical minerals, because there's no defined definition, so to say, of critical minerals, right? So each country has got their own list of critical minerals, but by and large, there is some consensus about what are critical, why they are critical, and how they are critical, right? So that's exactly the title of our 2-week program: what, why, and how of critical minerals, right? So the way that we're going to run the session is through interaction rather than me speaking all the time. Let's have a bit of conversational, so that I get benefit out of your wisdom and you get benefit out of my little knowledge. Okay? So coming to me, first of all, I'm from a town called Mantani, which is about 220 kilometers from here. And I studied mining engineering at Osmania University back in those days. Perhaps many of you were not on this planet, right? And then I went to do, I went and worked in two sectors. One is coal industry, the other one is iron ore, which Professor Narasimha spoke about. And then at a time that I decided that I should do something to better the image of mining industry, because mining is always at the curse of everyone, right? Everyone wants mobiles, everyone wants all the gadgets that we play around, but no one wants mining in their backyard. That had been the problem. It's a problem for centuries. What we forget is most metals that we derive or we get are out of, like they are the key underpinnings of any modern technology. So that's where my interest began with, because when I was growing up in a town called Mantani, as I said, and by the way, this town is incredibly powerful in that, it has given the Prime Minister, a proud Prime Minister to the country. Former Prime Minister P.V. Narasimha Rao hails from my hometown. And he is the architect of modern India, right? He's the one who changed the course of India. So, but that reason, I take a lot of credit that I come from that small town, right? So then I kind of started my research in the area of mine rehabilitation, and also mining is cursed because the mining of the past was never good, because there were no laws. And it's not only in India, but every part of the world. Even in Australia, in fact, in 2020, we produced a research report, a paper we published. We identified there are about 80,000 abandoned mines in the country. 80,000. Small, medium, and big range. So then my career kind of progressed from mine rehabilitation into mine tailings to critical minerals. in 2014, I went and spent a sabbatical at Yale University in the United States in the group led by Professor Tom Gradle. He's one of the gurus or pioneers in this area. And then that's where I started working with government of India that, India needs to work on this. My first official communication with government of India was in 2013. In fact, when we went to submit the findings, the report of our symposium to Ministry of Mines, the Secretary Ministry of Mines, one of the directors asked, when have you started kind of working with government of India? So I told, we started hustling government of India in 2013, and we are 2025, right? And not much has happened in that period of nearly a decade. Although there was a lot more urgency for a country like India to act upon, right? There were many areas where we had to do a lot of stuff, but we haven't done. So finally, at least, there's some momentum now. And that's where this is a very, very topical and very, very important. And hence we thought, we'll title it as what, why, and how critical minerals. Right? So, and then I work at Monash, and again, on a lighter side, I say to people that my university very much resonates with my name. My name is Mohan. The university that I work is Monash. On a lighter side, I say to people that, when you change the order of letters that make up Monash, it becomes Mohan's University. So, and I went to Monash back in 2007, and I was the first academic to be hired by the university to set up mining program. Again, Australia also hugely endowed with very rich mineral resources, right? So as I said, 80,000 abandoned mines. You can imagine a lot of gold, a lot of lead, a lot of tin, everything. You name any metal. And again, we'll come back to some of those numbers a little later part of this today's lecture. So that is a little bit about myself. And then at the outset, I must thank my good friend and a dear colleague, Professor Narasimha Doddi, a very dear colleague of mine, and again, an exemplary researcher who also finished his PhD from JKMRC, which is University of Queensland, one of the top. University of Queensland is again a top university in Australia, is one of the GOH universities. So they have got Sustainable Minerals Institute, right? Are you a product of Sustainable? Okay, who is that? Oh, okay, excellent. Yeah, Vigyan is also now part of our consortium, right? Yeah. So you are a joint PhD between IIT Delhi. Excellent, excellent. Yeah. So then we kind of co-founded something called Australia-India Critical Minerals Research Hub. Again, we'll come to address as to what were the key underpinnings as to why we began this, right? Then I went on to co-found a critical minerals consortium at Monash, which is again bringing researchers who are like-minded and who have got some interest in the minerals space. Now we need to work together to achieve the common goal or common objective, because our aim is same, but if you digress, if your efforts are digressed in different directions, then you won't achieve what you want to achieve in the time that we have got. The time is the key here in this, right? Critical minerals race. Now the race has begun, as Professor Narasimha alluded just before, as part of his introduction. China monopolizes the market. There are some minerals where China has a stake of 100%, meaning that there's no commercially available market outside China. And when you have such a market capacity, you can manipulate the way that you want, right? So again, as we are speaking, they're also touching upon some key attributes of critical minerals. Why? Why? Because there's so much monopoly that exists in one country, which is bad. It's whether it is China, whether it is India, whether it is Vietnam, whether it is US. I'm not taking on any any country. But the problem is such a huge market concentration is not in the best interest of the world. Say, let us imagine this way. For example, when the COVID pandemic struck the world, supply chains were one of the worst ones, kind of got hugely impacted, right? And if you see, even the Indo-Pacific now is one of the highly contested regions, and the sea route, where about 80% of world's trade happens. And now China tries to, kind of take control. When you have such a control freak neighbor in your neighborhood, then there's so much of vulnerability. And again, that too, I keep saying this on a lighter note again. If China were to fight a war, they don't have to fire a single bullet. They can just stop supplies of rare earths and everything will come to a collapse in any country, including the United States. But the advantage United States has is they've got an equally powerful market power in a sense, right? Because it's about 30 trillion economy, and they control a lot of technologies, a lot of investment. About 50% of world's investments or capital is in the US. And then if you don't supply rare earths, I will not supply the technologies. That's a kind of deal. Do we have similar advantage when it comes to India and China? Do you know what is the trade numbers between between India and China? Like how much we export, how much we import, and what is the net deficit in a year? Why we are talking GDP? Why we are talking these numbers? Because again, why, how, and what? That's part of the critical minerals. Any idea? And India's External Affairs Minister, Dr. S. Jaishankar, right? He keeps saying that this is something that we need to address very, very quickly. The trade deficit.
That trade deficit is lower, but China in that surplus even those 2000 crisis. And in case of critical minerals, I think we export a lot of lithium to China. Also,
Import.
Import.
Yeah.
Also the byproducts.
Excellent. So just to put some numbers to what she has said. What was your name? Sorry. Mosmi. Yeah, Mosmi. Anyway, we'll also do a bit of introductions a little later. Yeah, please.
China approximately close to $20
And
$20 billion. You are also in the number of
20 billion.
maybe 10, 15 Bitcoin.
Yeah, that's our exports to China.
So we have trade deficit with China.
That is a bit understatement. But anyway, thanks for, at least that is the worth of goods that we export to China. Yeah, yeah. Anyone else who wants to have a guess? Just a guess. Guess doesn't have to be perfect, right? And by the way, my good friend Sridhar is here. Sridhar and I began our careers back in those days, again, before many of you were born, in Goa, the most beautiful part. Maybe. Yeah. So what was I saying? We'll do a bit of introductions a little later. So just to tell you the size of the pie, there's a net deficit of about $100 billion US between India and China. That means China is positive. And same with the US, same with Australia, same with every country. China has the same kind of, because they produce everything. So what they have done is they invested in manufacturing, and for manufacturing you need raw material, and that's where they invested in critical minerals, they invested in everything, and now they are reaping the benefits out of that. So when you get oversupply or over concentration of these supply chains, then countries are going to face the problem that they are facing today. And no one has kind of thought the way that Chinese leadership has thought. So if you look at I think one of the Chinese presidents, whoever was in the 90s, um, um, the Chinese president's vision was if Middle East has oil and petrol, China has rare earths. That's the kind of vision that they worked towards. So when you now, everyone almost at the mercy of China. If they don't supply, your industry will collapse. And rare earths, many other critical minerals are so important to every modern technology that we are dependent on today. Whether it is your flat screens, whether your LED lights in this room. I'm sure some of you still have seen, or maybe in some places in India we still use the incandescent light bulbs, right? The very heat emitting ones, the light globes. So if you look at about 80% of your energy gets spent in emitting heat. Only 20% is actually spent in illuminating the room. But the LEDs, and before that CFLs. So LEDs, very least amount of heat, but very pleasant and very nice bright light. Again, that also requires a lot of key critical minerals. Have you heard of gallium, indium, germanium? Very tiny quantities. Again, we'll come to that also. Unlike bulk commodities, critical minerals are needed in very tiny quantities. Let me give you a small perspective. Sorry, some of the things that I'm talking now, I'll kind of touch upon several times during next few days, because they are very important every time that we remind ourselves, because that's how, and that is what critical minerals are all about. And anytime you have got a point to make, please raise your hand, because your perspectives are also very important in this, right? So, hi, welcome. What I was saying, if you look at, let me give you some numbers. Copper, one of the very important commodity, as we all know, right? Copper is considered as a gold of the future. Copper is required in every technology, whether it is renewable energy technologies, whether it is defense, whether it is windmills, whether any technology that you speak of, copper is going to be needed. And copper is going to be needed in large quantities compared to many critical minerals, right? The world market size of copper is about $250 billion, 250 billion US dollars, right? Do we have this whiteboard? Because I'm an old school teacher, so I want to write some things as I speak. Oh yeah, I got pens here. So if you look at copper, all of you are engineers, most of you? Metallurgy, yes. Copper, what I said, 250 billion US dollars, USD. That's a market size. So do you know how many elements are naturally occurring in a periodic table? Any guess? One? That's a total number. Out of them, how many are naturally occurring? See, have you heard of neodymium, ND? ND? Have you heard of praseodymium? Yeah? Lanthanides. Periodic table, right? Periodic table of elements. So if you look at praseodymium is not natural, but neodymium is natural. So now my question again is, what is the number of elements that are naturally occurring? About 90. Excellent. Yeah, about 90, right? 90 out of 90 naturally occurring elements in a periodic table, About 56 have been deemed to be very, very critical by 25 sovereign entities. So when you're saying sovereign entities, countries like India, China, Vietnam, US, UK, those countries. So every country came with their list of critical minerals. Right? So when you have that, and we are saying 56, right? That also includes copper, that also includes aluminum, for example, let's say. And these are the kind of elements that are required for energy transition. Energy transition. 56 are deemed to be critical, but they're also needed for energy transition. And energy transition also is very, very vital as we decarbonize our economies, but also at the same time, countries like India, where for most of our energy requirements, we depend again on imports, don't we? What is our energy import, like crude oil import percentage? Any guess? How many billion barrels of crude oil we import every day or every month, every year?
Close to 80%.
Exactly. So about 80% of our crude oil is imported. But again, now we are in a very fragile world, so to say, right? Geopolitically, it's very, very unsettled. Every day, Trump says that, I'm going to impose 20%, and next day he comes and says, I'm going to impose 50% tariffs. And India on the other side, keep holding on to their ground that, no, we are going to import our crude oil from Russia, we are going to have Venezuela, we are going to import it from Iran, but now for time being we have stopped importing from Iran. Because again, US comes and says, I'm going to put sanctions and we need a lot of investments, and US holds 50% of investments. So that's all geopolitics. Again, in the next session, we're going to talk about how the geopolitics are at play when it comes to critical minerals, right? So 80%. And one of the key things that when you want to become Atmanirbhar, Professor Balaji and Professor Narasimha during their introduction said, if you want to become self-reliant country, what is our population size? 1.4 billion, right? 46, yeah, it's increasing anyway, right? 1.46 billion. What is our economy size? What is our GDP? 4.2 trillion. $4.2 trillion, right? Around. It is forecasted to grow at a pace of 7%, close to 7%. But now IMF has said, 6.4. They reduced it to 6.4. We are the fastest growing major economy in the world, and we will continue to grow. One good thing about our country, like India, is domestic consumption is the one which is kind of, is the main reason why India's economy is growing. We are only dependent up to 77% on our, exports. About 93% of our growth is internally driven. Growing middle class, growing everything, right? Life expectancy, quality of life, and so on and so forth, which is good. That's one of the very important characteristics of a self-reliant country. Again, in contrast, when you look at China as a country, they are nearly close to 20 trillion economy, right? As the size of the economy. And the US is about 30 trillion. Right? But US also has got a problem. They have a debt which is 37 trillion. Right? So when you have that 7% export driven growth, which is, even for example, Trump puts every sanctions on India, we lose that 7%, which is unlikely because the kind of exports that India does to US are irreplaceable. For example, software services, Professor Narasimha was saying, right? No one else can provide, and you cannot build that capability overnight. So we've got a strong point there, but that's one of the very important underpinning. So again, coming back to naturally occurring 80% energy dependence, and that's where India wants to become energy independent. Energy independence is one of the key ambitions for an Atmanirbhar Bharat. One of the strongest or very positive points about that is we have highest solar radiation potential in the country, right? And also we have a reasonably good wind power generation, kind of capacity. But again, for that you need to create the infrastructure. And then, for example, all our automobile, fleet has to be converted into electric vehicles. Just imagine the scale. You require millions and millions of cars and two-wheelers, three-wheelers, and number of that. So that's going to be a transformational change for a country. But again, once you have done that, you are safe. That even, for example, all the energy supplies are cut off, you can still continue to, kind of produce what you want to produce, consume, export, and so on and so forth. So for that reason, again, it's so important that critical minerals are the key drivers. So again, it addresses some of why critical minerals, right? So I will just walk you through bits of why we designed the course as it is. How many of you have had a chance to look at the PDF that we kind of circulated? Did you hear? Yeah, all of you. What you find most striking in them? What like based on your area of training that you are currently undergoing, or the kind of work that you do at your workplaces, respective workplaces, what triggers you, or what is that more kind of appealing to you rather?
And then the technology that you need to capitalize on those existing things.
So mainly technology, you're saying, right? Are there any economists in this room? Yeah. Excellent. In fact, as we continue to unpack the definitions of critical minerals, we will come to an understanding that it's more about the economics that play a significant part in making a mineral critical than technology. Because there are a lot of technologies that are available, but one of the key underpinnings is the economics that contributes towards the mineral's criticality. So what is the kind of expectation is to discuss the preparedness of the Indian minerals industry to keep in pace with growing manufacturing industry from different stakeholders' point of view, right? Yes.
Which directory India manufacturing based to 30%. Behind that manufacturing is some very
Important.
you want to reach $1 trillion manufacturing. So this is the improved to reach for that. So that they can get it.
Excellent. Which organization you represent?
BT
Oh, BT Research.
Research.
Oh, okay, excellent. I think that's the best combination. So I think you brought up a very important point. How many of you have had a chance to read a book called India at 100? Or at least, have you heard of this book called India at 100?
Also,
ISB, professor at ISB, right? Exactly. India, if not, try to read this book, India at 100. So by 2047, India is going to be 100 years old as an independent sovereign country. Not as a civilizational country, but as an independent country, right? Civilizationally, we are the oldest civilization, right? So by this, so there, as you rightly said, there were many reports that have been kind of prepared, one by PwC, one by McKinsey, BCG consultants, yeah, and the PhD group, and so on and so forth. And also, I think Bain Capital, yeah, many consulting, many very reputable financial consulting firms have prepared, and even which is that one? Goldman Sachs, they also have come up with a report. So again, different people have projected about India's economy for next decade, next 2 decades, and so on and so forth. And especially this book is by Professor Subramaniam Krishnamurthy, who was former chief economic advisor to Government of India. I think he was the youngest, and also he is a professor at Indian School of Business. So according to his book, India is going to be about 40 to 50 trillion economy by 2047. So 2047 is how much? 25 years from now? And the kind of assumption that he based his forecast is now India is going to grow at 7%. Again, although IMF is kind of downgraded to 6.4, it might pick up because it's fueled by domestic consumption rather than external consumption, unlike China, right? So 40 to 50 trillion. And as our friend said, out of which about 20 to 30% is from manufacturing. Because manufacturing is the one which is very, very foundational or fundamental to that growth, fueling that growth. Because manufacturing is going to employ a lot of people, and it's also going to employ and create employment of high wage earners, not the low end of the fulcrum, so to say. I'm not saying that delivery boys and stuff like that. I'm not saying that's not important. It's also important. But when you have high wage salaried people, they also pay more taxes, and that means the economy will continue to fuel itself. So 40 to 50 trillion is what this particular gentleman's forecast by 2047, and at 7% annual growth. And if you look at Goldman Sachs, I think their prediction was about 27 to 30 trillion by 2050. So by the time you get into workforce, you all become middle managers in the workforce. And when I take my retirement, so that's where the country is going to be about 30 trillion economy, which is going to be really important. And again, one of the key thing is the manufacturing. And for manufacturing, again, you require a lot of raw material. And Professor Narasimha, during his initial overview kind of presentation, he alluded to another important fact: minerals diplomacy. Very, very important. Now, everything that's revolving, when Trump became the president, do you remember two things he said? One is he will ask Ukraine, where already billions have been spent in supporting the war efforts. He is trying to say that Ukraine, that part of Ukraine has a lot of rare earth deposits, and I'm going to kind of take advantage of that because I gave you money, so I'm going to take that money back. And which is the other country that he want to Greenland, right? Yeah, Taiwan is mainly because of chips, but they don't have minerals. As far as minerals are concerned, one is Ukraine, the other one is Greenland. Greenland also is highly endowed, richly endowed with a lot of rare earth elements. My friend Sridhar and I have been kind of hunting where to look for rare earth deposits in the world, right? So that's about the US and the UK, because Australia, UK, still the king of UK is the king of Australia, and king of UK is also the king of Canada, which are also richly endowed with a lot of critical minerals. So they're always having that kind of partnerships, bilateral partnerships. Then now China already occupied a lot of Africa. Major part of Africa is now under Chinese control because already their corporations, which are mainly government-funded organizations, they do mining, and even including in our neighborhood. If you look at, do you know Myanmar? Yeah, a lot of Chinese companies have invested in extraction of rare earth deposits, and then they ship the concentrate to China, where they process it, and then the environment is left to dogs.
And also, you see the scale of investments China is putting across the world. Just you can't imagine their strategy and the government supports and the way they are doing. They are doing a very massive scale.
Mm.
In India also, we have some policy makers and discussions. But China is making friendship with every country to get the critical minerals. So they want to keep their share of the dominance in the critical minerals. Still will continue.
It will.
We need to be very much cautious.
So when you have advantage of starting this 20 years ahead of everyone else, you will continue to have that advantage, right? No matter how much fast you may run, how much fast you may sprint, they will have their advantage. Exactly. First mover advantage. So if India has to realize this, raw materials are very, very fundamental. Okay, then I talked about briefly the scale of copper market, which is 250 billion. And then we also spoke about 56 minerals being critical for energy transition. And if you look at out of which, or if you put 30 out of 56 bunched together, the combined market cap is less than the market cap of copper alone. Again, in that, lithium is the big share, lion's share. Right? So lithium, including lithium, 30 critical minerals grouped together, the combined market valuation of that is less than the market valuation of copper as a commodity alone. So that shows that they're very tiny. That's on the market capitalization point of view. Then I'll tell you something called, let's say Australia exports about 850 million tons of iron ore. 850 million tons of iron ore. Iron ore is Fe2. Any ideas? O3 or O4, right? Fe3O4. One is hematite, magnetite, right? That's good. So about 850 million tons is exported. Gallium, we talked about gallium, right? Gallium is very important. Gallium is required for your semiconductor devices. Gallium is required for your LEDs. Gallium is required for your flat screens. Gallium is required for many specialist alloys. So the total gallium requirement in the world is only 700,000 kilograms. kilograms. One is in kilograms, one is in million tons. Right? So that's a kind of scale effect. So one is the tiny market size is very tiny, both from the financial terms as well as the volume terms. But one thing here, these come at very high cost. So for example, a 1 kilogram of gallium could be $1,400 US dollars per kilogram. But 1 ton of iron ore is only less than $120. Are you seeing what I'm saying? One is required in large quantities. The value is less. Bulk commodities, we call them as bulk commodities. And whereas the other ones are specialty metals, which are like gallium, they are required in small quantities, but they come at very high cost. Again, that's why. That also is going to address why critical mineral. Because critical minerals they require very special processing methods. And they ought to be ultra pure quality. When you're talking of high purity gallium, it's 99%, 99.999%. Okay, same with copper also, 99.999, right? So for that level of process to occur, your energy expenditure is very, very high. Your specific energy consumption, specific water consumption, specific everything is going to go up. And they are controlled by few suppliers, as I said. Like for example, if you look at gallium, about 80% is controlled by China. And gallium is required for semiconductors, which are produced in Taiwan. So if US says that I'm going to stop supplying you semiconductors, or China retaliates, I'm going to stop supplying you with gallium, which are key ingredients. So that's a kind of bargaining power. So now, hence, when Professor Narasimha, during his initial address, was saying that why Prime Minister had to go to 4 countries? What are the 4 countries that he went to? The Indian Prime Minister recently? What are the 4 countries? 2 countries in Africa, right? No, he didn't go to Congo.
He went to Tanzania.
It's your Prime Minister, you should know. Sorry? No, two in Africa. What are the 2 countries? Namibia. What's the other one? Ghana. These are the 2 countries he went to in Africa. And what are the other 2 countries? Brazil, in South America, and then Trinidad and Tobago. Trinidad and Tobago was just a stopover, diplomatic stopover. But if you look at these 3 countries, very, very important from critical minerals point of view. Now, when geopolitics are at play, when Trump is threatening with a lot of tariffs, now you cannot take China on head on, right? That's the reason India is playing very soft diplomacy, both sides. We are good with US, we are also good with China and Russia. Because China and Russia also has got a lot of rare earths, access to a lot of rare earths. So now he's going to SCO. So we are talking of why critical minerals again. Although we are talking of politics and geopolitics, one of the key things that we are addressing is why the geopolitics are at play. What is SCO, by the way? Have you heard of BRICS? What is BRICS? BRICS, right? BRICS, Brazil, Russia, India, China, South Africa. Good. That's good. And then, have you heard of Quad?
Yes.
What are Quad? Australia,
Japan.
Japan, India. This is the fourth country in Quad. The US, United States. So that's a Quad. There's something called sorry.
What is Australia?
Yeah. Australia, Japan, India, and US in Quad. And there's a trilateral partnership that India, Japan, and Australia has, which is called supply chain resilience partnership. Supply chain resilience partnership, which has 3 member countries: Japan, Australia, and India. In fact, our External Affairs Minister, Dr. Jaishankar, says the acronym is his first name, Jaishankar, right? So there are so many of those partnerships. Now India is also kind of, I've been proposing to Government of India that India should take a leadership role in establishing something called Global South. Have you heard of Global South?
Asian.
Huh?
And Asian, right?
Right? Yeah. What is Global South, by the way? So I'm just trying to trigger how geopolitics are at play, why people are doing what they're doing. We're trying to unpack why you do what you do. Why India wants to take a leadership role in Global South?
Population.
One is population, yes, Global South. First of all, what is Global South?
Emerging economies, Asia, Africa.
South Asian.
Southeast Asia, right? South Asia, Southeast Asia, Africa, South America. So if you draw a kind of line, they all fall south of the globe. That's why it's called Global South. And when India hosted G20, it gave a permanent membership to African nations, African Union. That was the first time that it was given. Again, with that strategic long-term vision. Look at, again, Africa as a continent is still underexplored, meaning a lot of minerals are present in Africa. If you look at cobalt, right? Why cobalt is required? CO. Why do we need cobalt?
The airlines and the space.
Sorry?
Airlines and space industry.
Yeah. Most importantly, the battery. Right? Medical, of course, cobalt. And even pharmaceutical industry, right? Cobalt is very important. Do you know where majority of cobalt is produced in the world?
Yes.
DRC. What's the percentage of production?
80%.
About 60 to 70%. DRC, Democratic Republic of Congo, right? That's where it is produced. So likewise, PGMs. Have you heard of PGMs? PGMs. Any excellent platinum group of minerals. How many of them?
6.
6 of them. So there are about 6, a bunch of 6, platinum, palladium, and so on and so forth, right? So about 6. Do you know how many are rare earth elements? REEs? So we talked about PGMs, which are 6. How many are under rare earth family? 17, right? If you look at lanthanides in a periodic table, how many of them? Lanthanides are about 15: lanthanum, cerium, neodymium, praseodymium, dysprosium, terbium, and so on and so forth, right? So there are about 15. Plus you add 2. Which are there? Scandium and yttrium. You add these two because they possess similar characteristic features to most rare earth elements. Why rare earth elements are so important? Because at least among 17 of them, 4 are very, very important. What are they? Nd, Pr, Dy, and terbium, Tb. These are naturally magnetic in properties. They possess naturally magnetic, these 4 of them. And scandium has very special metallurgical property. When you add scandium to, say, for example, most aircrafts have to be lighter, right? What's the typical aircraft weight? That the Airbus or the one that kind of crashed in Gujarat. What's the typical weight of that aircraft? Have you ever wondered how much?
Including fuel.
Huh?
Including fuel.
Including fuel. By the way, what was the amount of fuel that was present in the aeroplane that crashed in Ahmedabad? About 120,000 liters, right? Apparently, they consume about 4 liters a second. Most of these 787, right? So, I think the overall weight of that was about 320, right? About 300 tons. Yeah? That's a weight. So one of the important feature for any metal or any thing that gets into manufacturing of aircrafts, it has to be lighter metal, but at the same time it has to be stronger. Because the one, remember that it had an emergency landing in Jammu Kashmir a few months ago. The front portion got kind of eroded. So when you cannot have kind of some of so eventualities happening when you're in the air. And nowadays, people are experiencing a lot of turbulence and kind of activities. So it has to be strong enough. Aluminum is the lighter metal, but aluminum is very weak from strength point of view. So when you add scandium to aluminum, it becomes like steel. Steel is very strong, whether it is tensile strength, compressive strength, and everything else, right? But very heavy. So we need a metal, or at least an alloy, that is as strong as steel, but as light as aluminum. And that's where you have these alloys. And most critical minerals are used in making alloys. So why critical again? Because they possess very important characteristics such as special metallurgical properties. They possess magnetic properties. They possess luminescence properties. For example, we talked about gallium and indium. But they're also highly concentrated as markets. So we are trying to address why critical minerals. And they're also tiny markets. Didn't we see? The total gallium requirement in the world was only 700,000 kilograms. But whereas iron ore, when it is a bulk commodity, both in terms of volume and also the value. Copper was $250 billion market. And 30 critical minerals put together are less than copper as value. So again, why critical minerals, right? So this is something that we will learn by the end of this 2 weeks program. And that's why we've got some stellar people coming, with different specialist backgrounds to kind of educate us in terms of, what these are. So I think lecture 1 and 2, we are just trying to again understand what is the base scenario, what is the current scenario around this, what are the geopolitical factors and the risks, pressures and opportunities in critical minerals. And we'll also try to understand, appreciate what are the key obstacles. So there have been several attempts time to time, because everyone, if I can tell you, the first shock to the world around rare earth metals came in 2010. It's almost how many years now? 15 years, right? Because Japan and China had some territorial dispute over a small island. Because China, you can, even if you shout a bit loud, people on the other end can hear you. That close they are, like Sri Lanka and India. So there was a small island that China saying, I want to put my military base. And then Japan said, no, you cannot do that. Because again, you have to think strategic implications, long-term strategic implications of having your enemy or even your close friend or who is pretending to be your close friend to be at your backyard, right? To be very careful. And then what China has done, simply they said, okay, if you are not obeying to what I say, I'm going to stop supplying you rare earth elements. And then world came to a very sudden shock. If you don't get rare earths, a lot of technologies that gets manufactured in Japan, they will be completely paralyzed. The entire industry, all these Mitsubishis, Hitachis, and all of these Japanese companies will be in dire need of a lot of these critical minerals, and then especially rare earth elements. And then it will kind of paralyze the entire economy. That was the first shock. But again, time to time, then people said, okay, if that was the trigger, then people started acting upon. Once you see a problem, then you understand the problem, then you start making moves to kind of address the problem, to kind of de-risk some of the important supply chains. Then whenever other countries started standing up some companies to produce rare earths, process rare earths, refine rare earth elements, China had that 100% market capacity, right? Market power. When you have such 100% market power monopoly, you can dictate, okay, this is the price that I'm going to sell you. And what happens as a result? For example, if Japan is manufacturing some things that are going to need these NdPr, dysprosium, and so on and so forth, what will happen? You have to buy them at premium price. That means your products will become unviable for markets. In fact, that's the reason when Trump said that, he threatened Apple not to manufacture in India and then manufacture in the US. A lot of experts have said if same Apple phone has to be manufactured in the US, it would cost you $5,000, bloody $5,000. Who will pay $5,000 to buy an Apple iPhone? But if the same thing is manufactured in India, you can manufacture at $600. Even if you want to sell it, with 600 more, $1,200. Where is 1,200? Where is $2,500 or $4,000? So that's a bargain. So back in 2020 also, China said that I'm going to stop supplies of gallium and germanium and indium, which are important for semiconductors and chips. The entire chip manufacturing kind of got a bit of shock, and it would have been kind of sabotaged in a sense. Then again, US kind of intervened and said, okay, we'll come to an amicable solution, a midway to tackle the issue. So when it's all supply demand, right? When you got low price elasticity of supply, supply demand, you're right. Price is sensitive to both supply and demand. When you got high demand, means you got supplies are not meeting your demand, then your price is going to be very high. And when you flood the market, then your demand will crash and the price will crash. And that's the same tactic China has been very, very strategically using to their advantage. And that's exactly the reason why other countries, whoever came up and said, okay, we will stand up another rare earth company. For example, if you look at in Texas, in the United States, they opened a mine called Mountain Pass Mine, where they produced high-grade rare earth concentrates and then trying to set up a processing plant. Then what China does is they flood the market with cheap rare earth magnets. And then Western markets they work differently to the way Chinese markets, because China, everything is state-owned companies. State-owned companies gets a lot of subsidies. State-owned companies can work according, they can manipulate the markets the way they want. So whenever these Western companies started, or at least started thinking about starting a company, when the demand was at its peak, when the prices were at high, then it made sense for them to kind of start mining, start processing. Right? It's all about that simple price, cost, price, and revenue dynamics, right? So the simple business logic is profits are revenues minus cost. That's a simple equation, governing equation, right? Whether you want to start a restaurant, whether you want to start a cafe, that's the same thing. Right? If your revenues are greater than your cost, then you will start making profits. If you are just equals to them, you are breaking even. If you are this way, you are loss. That's exactly the equation that China very conveniently manipulates. So what happens when supply, again, the other important thing is supply and demand. When there's oversupply, demand is less, means prices are, so price is sensitive to demand and supply. Same, it's vice versa, right? So when that kind of things happen, when the prices were at their peak, many Western companies decided to kind of start venturing into this kind of markets, and they take it to a reasonable production stage, and then suddenly China floods the market, and then they crash. Because there's nothing called government as a business in these countries, right? In most Western markets, whether it is Australia, US, or Europe, it's all private. There's nothing called public, or. So now governments have realized, unless there's a public intervention or public sector intervention, it's not going to work. And now government is putting a lot of subsidies, a lot of funds, and so on and so forth to make them viable. And the other important reason is, it's again that price premium. If there are two suppliers of rare earth magnets, let's say one supplier is coming from China, the other one is from Australia. Australia, they cannot produce at the rate China produces. Right? For example, let me give you some perspective. Like, for example, if China, a daily wage of a person may be $10. In India, there are many people whose daily incomes are less than $2 also, right?
You take local.
And again, like in Australia, no way. Like you cannot pay less than, I think, $30 minimum wage per hour, not a day. So these we are talking of day, and we are talking of an hour. How can you become competitive? Unless you have completely, fully automated system. You've got fully robotic systems, completely autonomous systems, no human being involved. Because one, it's very sparsely populated countries. Human capital is very low. and cost of human service is too high. So no way Western markets can compete with China. So again, how? Critical minerals, right? So when that's where India has a huge advantage. One, we have got massive human capital. If we really use our human capital to our advantage, we can be a game changer.
Here is the main issue. Almost 13 years demographic period obsolete. And even we have maximum in the next 9 years. In the next 9 years, how these workforce will be trained to that level?
Yeah, I think that's where probably, again, I go back to Professor Narasimha's comments earlier. So government of India has finally said, this is where we're going to invest. So for example, this program itself is a testament to that, right? We want to train some younger, next generation folks to at least be sensitive about why critical minerals, what critical minerals, how critical minerals. So then again, depending on your own intellectual rigor, you will work in your own areas. For example, my good friend Sridhar is a advisor to a commercial entity. So he is now on the hunt of critical minerals. Where can I find gallium? Where can I find rare earths? Where can I find something else? So that the company that he's advising will start investing, making some, futuristic investments. And for example, a friend is metallurgy come financial. So metallurgy is a very key component of critical minerals. One of the key things, again, another important reason why rare earth elements, although the name rare, they are not rare. There are plenty. But the problem is, I told you that there are 15 of them. Mining is easy, processing is easy, but separation is incredibly complex. Separating one from another is incredibly complex because the variation in difference density between one another is very tiny. See, in order for one to be separated from another, you have to have some special characteristic features, right? And when you have very overlapping kind of characters, it's very hard. And that's where you end up spending a lot of energy, a lot of chemicals, a lot of everything. And hence, you cannot do that in a manner that is environmentally sensitive. And China has done it because China does that in different parts. Right? Again, this is a classic example of how China does it. So China produces about 60% of world's rare earth as far as mining is concerned, and they process about 80% of rare earths. That means 20% came from backdoor. No one knows where they came from. And when it comes to rare earth magnets, 98%. That means absolutely there's no commercial market outside China. Look at that monopoly. 60% they produce, 80% they process, 98%. And the scenario is same with many critical minerals that we'll speak of. Okay? Any thoughts, any comments so far? From your own personal perspectives, what you think? I'm not teaching you anything that you don't know. Only I'm trying to reframe in a way that it makes sense. You know all these concepts, right? Economy is one thing, manufacturing is another thing, productivity is another thing, and making supply demand, we know a lot of it.
So considering all challenges in the global ones,
Yeah.
and we need to think something that is there in our hand from countries, right? So as you said, we have manpower, the students or working professionals, but the need is the resources are not in our country. Maybe animal resources are. So how can we address this huge gap to cope up the for supply like China. So how we can contribute from our side? Like, what is the plan? Anything that we can go as for?
I think that's a brilliant question, right? Where do we start? Yes.
Can say, of course, for the minerals related, our country is not that much rich, but we have some alternate recycling. That is the one way we can able to capture.
Okay, that's a very good point that you brought up. And now again, that will open next 1 hour of discussion. Very brilliant.
So that's where now India is using the technology and exploring these methods. Because many of the years materials we got in the past, and also what that is. Many of the reports are in forest based.
We can incorporate solar
Absolutely. Multi-pronged approach is what you're suggesting. Yeah, exactly. So do you know metal value chain or mining value chain? If you look at what is involved? So my friends who are familiar with this, they can understand what it is. Yeah, that's a good one. Again, one is downstream, one is upstream, the other one is downstream, right? Yeah. What is that? Trenching. Anyone else? Open pit mine. Mining, right? That's mining. How do we write processing? Let's put it this way. I call it a process, right? Simple processing. So mining, processing, or beneficiation, we call it. So beneficiation includes two primary activities. One is comminution, separation. Professor Narasimha is guru in this area, right? By the way, Professor Balaji mentioned that Professor Narasimha got a very coveted award given by Government of India, Ministry of Mines. It's called National Minerals Award, Geosciences Award. So it's very prestigious, right? Very few people get it. And unless you are an outstanding scientist in that area, you won't get it. So congratulations again, Professor Narasimha. Then what comes next? So let's say beneficiation, then is it refining or smelting? Smelting? Refining, and then smelting.
Hydrometallurgy.
Yeah. So probably anytime if you want to move out, please walk out and walk in. There's no restrictions. It's not a typical classroom per se. Yeah. So let's say you get 2% copper as ore, copper ore, right? Copper ore. And gold, how many grams you get?
1, 2.
Yeah, that's cutoff grade. But generally, average grade would be
6 to 8 ppm.
6 to 8%, 6 to 8 grams per ton. Typically, if you get 6 to 8 grams per ton, that's considered high grade ore. Like if you dig up 1 ton of rock, if you are able to fetch 6 grams of gold, that's good enough. That means you can bet upon that particular prospect. Then what you do, you take here. Here we do something called concentration. What we prepare, we concentrate, ore concentrate. So when you process that through various mills and crushing and grinding and separation and so on, what you prepare is you prepare 30% concentration. or you make it 30 grams per ton. So how many fold improvement you made? 6, let's say 5 grams to 30 grams per ton. Only? So 5 grams per ton to about 6 times. And then when you take it to refining, it ought to be nearly 98% purity. And then when you take it to smelting, it has to be 24 karat gold. Whatever, 99.99% purity. So same with copper, 2%, 30%. Here you take it to 99.99%, and then you take it to last stage, which is 99.99%. So that's a kind of typical value chain. So this is a typical primary production route, we call it. Primary production is you mine it, you crush it, grind it, process it. That's primary. Then our friends talked about second thing is secondary resources, which is called urban mining. Urban mining. A lot of electronic gadgets, as Professor Narasimha said, if you look at your mobile phone, which is nothing but a bunch of 50 metals, right? Typical PCB, printed circuit boards. Again, in one of my presentation slides, I'll show you like how your PCBs have evolved from 1980s to 2020s, right? So where after a product has reached its end of service life, it will end up in dustbins, and finally it will end up in either landfills, or sometimes it is taken to recycling facility where you again crush, grind, and separate, and same thing, same method, where energy intensity would be far lesser compared to primary. But our demand is overshooting, right? And hence, you require primary and secondary, right? So when it comes to what strategy we should have, look at, again, you spoke about we have not many reserves. And again, coming to your point, even if we have reserves, they are in the reserve forests or, ecologically fragile environmental conditions where you cannot disturb. For example, I began my career in Goa, and I think by 2015, Supreme Court has mandated that the entire mining activities in Goa comes to a complete stop, because there was a lot of massacre that was happening under the pretext of mining, where people were becoming wealthy who were miners, whereas as a government, they were getting less revenue. The mining companies were making billions, but they were not paying taxes. A lot of illegal shipments used to happen, and they would kind of manipulate the balance sheets. On the actual ground, you will see environment completely ruined, because when you produce more, you show less on your paper, and you pay less royalties or less taxes to government, and you export more, and you become rich in the process. Whereas the liability still is on the governments to fix the environmental damage that you've done. Because they do barely, do some plantation and then say, oh, we have done enough of our responsibility. So that had been the problem. And then Supreme Court said, no, let's stop it. So what India lacked is, traditionally, we have not put a lot of money on exploring the country. There are many parts of India. For example, if you look at a lot of eastern belt of India, very high monazite deposits are present, mineral sands, which are very rich in rare earth concentrates. Look at all the way from Orissa to Kerala, the beach sands, if you look at, they've got very high percentage of rare earth metals, especially NdPr. So then that means India, we have not put enough emphasis on exploration. For two reasons. One is, until recently, I think MMRD Act, they've changed only 3-4 years ago. Only then they kind of said, okay, foreign companies can invest in exploration. And before that, it was only this domestic companies. And domestic companies had enough on their plate, like Tatas, Birlas, everyone. So, for example, Birla, Aditya Birla Group, Hindalco, they are busy digging up for aluminum. Why would they bother about something else, which is a very tiny market? So that means we have not done enough exploration of the country. And same, even the other countries like Australia also has. But Australia, what they do is, while mining is happening, some of the mining revenues gets kind of spent on exploring the territories and the states and so on and so forth. So traditionally, we lack systematic exploration. Then how do we address? Is now government has said, okay, let us do exploration. Companies who are into exploration, let's give, I think they've given up to 50%. For example, if you're an explorer who is exploring and then you discovered a big deposit, whatever money that you put, 50% of that money will get back to you. So that's an incentive, tax incentive. But again, still a lot of people express the problem in that is, if you are the explorer, if you found a big deposit of gold, you will not get entitlement to do mining of the same deposit. In the past, it used to be the case. For example, if you held an exploration license, you will be preferential candidate to win mining license too. But again, there are pros and cons. And then again, coming to your point of how do we deal with mining in ecologically fragile environment, which in most cases in India is, because if you are trying to accommodate 1.4 billion people in your urban settlements, and even the rural, if you look at, I come from a very mid-sized town, about 1 lakh people, hardly any space. Almost, every building is touching each other, and hardly any space for even municipal dumps. A city like Hyderabad or Mumbai, you cannot imagine what the municipal authorities are going through. I've been to some of the facilities managed by, I think, which is that Ramki Group in Jawahar Nagar. It stinks, that area, where BITS Pilani operates their campus in Hyderabad. What we don't understand is, the problem is humongous. But just imagine, what is the population of Hyderabad, Twin Cities, Secunderabad and Hyderabad? About 1.2 crore. Each household produces about 4 kgs of solid waste a day, and then multiply that with the number of households. So it's a huge problem, and the same problem with mining also. And hence, India is now thinking, one, okay, explore some of the territories which are rich in mining or minerals, which again, exploration incentives are given. Secondly, mining, rehabilitation and resettlement is a big issue. This is the question that I keep asking our colleagues from GSI. If you look at National Highway Mission, Minister Nitin Gadkari, man of highways, we say, right? Almost every day they construct about 9-kilometer stretch of highway. As far as highways, they are able to achieve, land acquisition very quick and rapid, very high, very efficiently. But when it comes to mining, most public sector undertakings, they are struggling. Whether it is Coal India Limited, Singareni Collieries, everyone having huge issues around acquisition of land. And rehabilitation and resettlement is also big. Because I was just, yesterday I was driving past a mine where there used to be a village. Now it has become an open cast coal mine near Peddapalli. That was a complete town, or a small hamlet was completely, relocated. and that went into courts, went into number of public hearings, number of, but it takes time. So given that, typically even in Australia also the same, typically from discovery to mining, it takes about 12 years. Exploration, development, and mining and processing. The typical cycle could be anywhere between 10 to 13 years. That's called gestation period. So that means if you start eyeing on a particular deposit today, it will only become operational some 10 years later. So then your demand will not stop until you start sourcing the material locally, right? So hence, multi-pronged approach. So what government is thinking is, you produce what you have in the country, and then you look what you don't have in the country. And that's where minerals diplomacy, as Professor Narasimha was saying, Prime Minister is on his job to kind of get material wherever. And then I talked about SCO. What is SCO? I asked, what is SCO? Organization, right? So now, after 7 years, Prime Minister is going to China. Because if China stops the way that geopolitics are currently being played, if they say that I'm not going to supply rare earths, again, Indian industry will suffer. It will be hardest hit. And if people don't have jobs, then there's a lot of public unrest and so on and so forth. So you have to be, it's really, just imagine from the policymakers' point of view, US is very important from capital flow, for investments to happen. 50% of capital is held by US. Russia is important because cheap oil. China is important because they hold rare earths. And people are important. If something is disrupted, we will say, oh, what this useless government. So just imagine what tremendous pressure that they are under. It's a very balancing act. And a lot of capital, a lot of technology, either in Europe or in United States. So we need money, FDIs. We need capital. We need technologies. We need jobs, high-paying jobs. But in the short to medium term, we also need supply chains. Right? So that's why after so many years, he's heading. Right? Any thoughts? Any further thoughts? Any further questions, comments?
I don't know it was that and there was some disruption in the semiconductor industry based on imports, and a car took around 18 months of period to deliver due to that disruption.
Absolutely. Now, yeah. If you look at Tesla, why you think Tesla is delayed setting up or making inwards into India? India has a huge market as far as demand is concerned. But if Tesla antagonize China, they'll cut off the supply chains. China wants to continue to benefit from their monopoly. Who wants to give up on that? Everyone wants that market power, right? No one wants to give up on that. So again, until you equip your country so that you continue to have supply chains. Hence, a lot of variant versions of these battery mixes have come. NMC, NFC. What is that? Do you remember any of them? NMC is nickel, manganese, cobalt. LFP is lithium iron phosphate. I think India has now adopted LFP being the most optimal for our own domestic market because it doesn't require cobalt, it doesn't need nickel, it doesn't need many other small elements. It only requires aluminum, it only requires graphite, it requires lithium. typically, if you're looking at about 160 kilowatt hour kind of battery that you're looking, a typical Tesla battery, about 60 kilowatt hour capacity, you require about 160 kilogram of metal, out of which graphite is about 50 kilograms, and the rest of them are in tiny quantities, right? So how can you kind of, again, Professor Narasimha also talked about substitutions. When you don't have, necessity is mother of invention, we say, right? When you don't have, you have to work around it. So that's exactly how people are trying to kind of address the issue. When you don't have ensured supplies of cobalt or nickel, and when you have to get them, they come at high price premium. Again, that increases the cost of production. Then the best way is to not to use them in your battery pack.
But I guess India is trying to cover Australia or
Yeah, again, that's a very good question. You know, a lot of times when we meet the diplomatic people who manages these kind of supply chains in both the countries, one of the key frustrations that we keep hearing is there's so much talk but no action. Again, why? Because 10 years, who wants to wait? I told you, for example, if you want to set up a mine in Australia, it takes nearly 10 to 12 years. So what you are putting money in today, you will only start reaping the benefits after 12 years.
because partnership I don't know critical updates.
No, only investments are going in, but no tangible outcomes of that are seen. That's the main problem. Okay. Any questions, any comments so far? Yeah? No? All good? Okay, so let us look at some of the key. So how much time we have?
Can we break at 1:30?
20 minutes, yeah. Okay, yeah. Okay, then few definitions of critical minerals. There are variety of different definitions that have been kind of proposed by various research groups, governments, and also corporates. Right? Critical minerals are important for governments, for corporates, and also for manufacturing companies, and other important stakeholders. Again, important stakeholders include academic and research, right? We are the ones who create new knowledge, and that's what is going to be used by commercial entities, and in the process, governments as a facilitators will benefit from the royalties and taxes which will come to help governments to spend in the social economic upliftment of the societies in which they operate. So there are, the definition one here is a mineral is a critical mineral if there is a risk of supply disruption. So most critical minerals have this problem of supply disruption. As I told you, the example of China, rare earth elements, 2010, the first shock came by putting controls on rare earth supplies, right? So there is a supply disruption risk. Gallium, same problem. Silica, high purity silica, same problem, which is again used for semiconductors, even solar panels, wafers for, the silica wafers that are going to be needed. And if the consequence of such disruption would be great. Again, this is where one important fact that I want to kind of bring to your attention. So the total rare earth rare earth value chain, not rare earth, the total market cap of rare earths is only $3 billion US, which is tiny compared to the previous one that we talked about, right? Copper. What was the copper size of the pie? 250 billion US. It's nothing. $3 billion is nothing. You know the state of Telangana? What is its GDP or GNP? Any guesses? Which is the main contributor of India's GDP or GNP? Which state? Maharashtra, right? Second is Tamil Nadu, by the way. Yeah, that's Maharashtra is about $350 billion. Telangana is about? No, slightly lower. I think it's about 160 to 170 billion US. So 3 billion is very tiny, right? As a market for rare earth elements is only $3 billion. But lack of this supply, it's going to impact on 4 trillion economy. Just imagine, 3 billion will impact about 4 trillion economy. Right? So they're very, very important. The disruption is going to be huge. If rare earth supplies are stopped, India will come to a standstill. If I make a statement like that, the Indian defense system will collapse. And when you have defense manufacturing as one of the mainstay of your manufacturing focus, you cannot, right? So one, energy independence we talked about, where 80% of our crude oil is imported. If you want to be energy independent, you have to have sufficient capacity to. But by the one good thing is, it's quite heartening to hear the news that India achieved 50% renewable share ahead of time, 2 years ahead of time. So if there's a willingness, we will achieve. That's a true testament to the capability of the country. And India has pledged to meet net zero targets by 20?
47.
No, net zero. 20? No, that is 20? 70. That's correct. 2070. Most countries have said they will achieve net zero by 2050, but India said 2070. But I think we will achieve much before that. The way that renewable energy share of our energy is 50%. That was actually 2030 was the ambition, but we already achieved it. Again, that is from energy security point of view, energy independence point of view. 80%. So if you cut down, I think it will be worth checking what will be our crude oil, 80% crude oil import, how much $1 billion that we spend every year in foreign exchange. When you have to import, you have to pay in dollars, right? What is the total forex reserve that we have in the country? Just some number crunching. Now, why we want to be sensitive? Because geopolitics are at play, right? The core of critical minerals is around geopolitics. So we said that our economy is about 4.2 to 4.3 trillion, yeah? And our annual federal budget is about 600 billion US, right? And our energy imports, our crude imports are about 80% of our total crude requirement. It would be good to check how much that means in terms of dollars. How many dollars we have to forego every year on account of importing something. And that's exactly the reason why Trump is getting annoyed. Because Russia, he wants to cut off Russia, starve in terms of dollars. So no one will buy in rupees, right? 220 billion. It's a huge money. Right? So on year, if you're going to import 220 billion, that means you're giving away. And our total forex reserves are about $700 billion, right? 700 billion, which is increasing very fast, very rapidly. So whether it is mineral imports, crude imports, or any imports, we will have to give up our forex. And that means it will lead to inflation and so on and so forth, right?
So 158 billion
What is that?
import bill.
Import bill, crude. So it's a lot. If you look at, that's your size of the economy, budget, annual budget. When finance minister proposes a budget, it's about 600 billion. 150 billion out of that would be that, right? Almost 1/4. It's a huge, yeah, 1/4. So again, whether it is minerals trade, whether it's this trade, that trade, but one thing that India can do is, because of our human capital, we can do value addition. I'll come to that very important thing. Value addition in critical minerals plays a huge role. For example, Australia produces 50% of world's lithium concentrate. Australia produces world's 50% lithium concentrate. But it only derives just 1.5% of lithium value chain. Total lithium value chain, from lithium to lithium carbonate, lithium hydroxide to the final batteries. You look at the complete value chain is valued at about $150 billion. Out of which, what share Australia gets is only very tiny fraction. The lion's share goes to China, about 80 to 90%.
Because of the earlier contracts.
No, what Australia doesn't do is any downstream. They're only just involved in upstream and concentrate. Say, for example, if they dig up spodumene, which is 1% lithium, they upgrade it to 6% and then they ship it. Where much of the downstream processing happens in China. The value is there in downstream, for the downstream, because you will use your people who get paid high and who in turn pays taxes to the government. So that means you're alleviating the economic opportunities, employment opportunities, tax revenues, and the total value is 150 billion, only 1.5%. That means only 1.5 billion Australia receives by sending 50% of world's lithium to China. And where the rest of the money is going? China. It is creating jobs in China, for China, and then the rest of the world just buys stuff from China. China benefits again there. All other countries are not benefiting as much China is doing. So that's where now everyone is hell-bent on creating manufacturing infrastructure, downstream or midstreaming at least. For countries like Australia, they're only the main focus is currently midstreaming, maybe up to kind of concentrate and little bit of processing. Because one, they cannot compete with China. As I told you, the human capital is very expensive. A typical mining employee in Australia gets paid about $110,000, $110,000. $110,000 can buy 10 mining people in India, isn't it? Or maybe even more. Right? So that's a size and scale effect. China mastered that, like bulk production, cheaper cost. Initially, they never bothered about quality. They were mainly focusing on quantity. And as they became better economy over time, then now they're focusing on more, R&D, innovation, technology-led focus, and quality.
So I think both of us, we have covered cheap labor with China and India.
And we have demand also, huge demand. Because India has now realized that let us do, and hence again, I was talking about Tesla. Why Tesla did not do, but Minister Nitin Gadkari was very insistent that he was persistently insistent about Tesla doing their business in India for India, not that they manufacture in China and bring the cars here. Then they used to put a lot of punitive taxes, import duties, and same Trump is doing the same. But West can never compete with human capital surplus markets like India and China and Vietnam. Even look at software, how India's software industry has thrived. Because again, if you have to pay a director a salary of $250,000 salary, with that money, they can have at least 10 good quality engineers here. Offshoring. But now everyone was trying to get onshoring of some of that. Because they also need jobs, right? If everyone, otherwise those countries have to just sit and eat, do nothing. When I went to Australia, there was a big GE's Holden company used to have huge manufacturing base in Victoria, in Melbourne. And gradually it died because everything got shipped to China, Korea, where cheap labor, cheap markets, cheap everything. And now everyone is repenting, what have we done? Because even from pin to plane, you have to depend on external. So it's the same. When I was growing up again, in India, probably we had very strong manufacturing base for toys for children. And we systematically killed our own industry. And we also, for countries like Australia or Canada, where people are in scarcity, it makes sense, right? And they are wealthy countries whose per capita income levels are about $50,000 a year. In India, I don't think so. When you are saying $2 a day average wage of 60% or 70% of our people, our per capita
It is 2,000
about 3,000 to 5,000, I think.
Rated average 2,000.
Oh, is it? Okay. So when country becomes, say, 20 or 30 trillion, one of the key problems that we will have is the parity, wage parity. Not only purchasing power, but also wage parity. So someone will get paid millions and someone gets paid still, they're barely getting $2 a day. You should all watch maybe tonight a lecture by Professor Raghunath Mashelkar, R.A. Mashelkar. He was former DG CSIR labs. A great scientist, a very admirable scientist, chemical engineer. It's called, the title of his talk was Gandhian Engineering. Please watch it and then we can discuss. Gandhian Engineering. The concept is more from less for more. More MLM, more from less for more. Gandhian Engineering. And he gives a lot of examples like, Ratan Tata's nano car invention, from that to Jaipur food. For example, for some reason, if someone loses one of their limbs, if you have to ampute that, there were very expensive kind of prosthetic arms, legs that were in the Western markets, which would cost you about 10 to 12, 20, 20 anywhere between $10,000 to $20,000. But a common man whose wage is $2 a day, less than $2, can they afford? How many months of salary that would be for this common person? Can they afford? Then came, that one of the things that he talks about is if you have to make any venture successful in India, it has to be not low cost but ultra low cost, and hence the Jaipur leg, or Jaipur foot became very famous. And same with Tata Nano. I think apparently one day Ratan Tata was driving, and then he saw a family of 5 people on a bike. That's the same story, compelling, Now, a scooter is about, say, 50,000 rupees. And can you make a car which is one? So it is reverse engineering he talks about. So please watch that. It's a very, very beautiful lecture. I love it. Okay? So disruption is another important underpinning when it comes to defining critical minerals. Then the other one is a mineral is a critical mineral, an element contained in a mineral or downstream product of a mineral. Yeah, that's about mineral. So here, minerals used in agriculture, critical minerals, minerals used in clean energy production, minerals used in defense. So that's the basket that we are talking of, critical minerals. I think I'll stop with the next one, next slide being the last slide, and that would also probably make us arrive at today's. Oh, sorry. By the way, another important thing here is we often refer to elements as simplification with problems. So again, if you look at lithium, I talked about lithium value chain. Lithium is not critical at the mining stage or processing stage because world's 50% of lithium comes from Australia. But lithium is a critical mineral still. So lithium criticality does not come from lithium mining or processing, but further downstreaming. So as you go further, for example, lithium mining, lithium processing, then electrochemical processing, and then I think the next stage is battery anode and cathode manufacturing, and then assembly. So as you go further downstream, you will see that China controls again 90%. As you go from mining, Australia 50%, but when you go to processing and assembly, China has about 90% share. That's where criticality exists. So it's not at the mining or processing stage, but at the further downstream assembly. So that's another important thing when it comes to yeah. So these are some of the definitions from Australian critical minerals strategy. If you look at essential to our modern technologies, economies, and national security, specifically the priority technologies set out in the critical minerals strategy, for which Australia has enormous geological potential for resources in demand from our strategic international partners. For example, as I said, there were 3 or 4 key international partnerships that we spoke of. One is which India is part of. One is, as I said, the Quad, 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 which is Australia, Japan, India, US. Then second one is Minerals Security Partnership, which is led by US. It is led by US. There are about 23 member countries. including India. That's Mineral Security Partnership. The third one is Supply Chain Resilience Partnerships, which is, I talked about it, Jai, and Dr. Jai Shankar always keeps reiterating that it resonates with his personal first name, Jai. And fourth one is Australia and India also have a bilateral critical minerals partnership that you refer to, the 5 projects, right? So one of the key things that Australia, through this particular partnership, has said is Australia has a lot of technology. There is something called, another important term that you should be aware is METS, METS, mining, equipment, technology, and services. METS. Australia's METS capabilities are tremendous. I think they are unparalleled in the world. They are the best in the world. Now, Australia has set up a completely autonomous mine, was set up by Rio Tinto, where you will see absolutely no person on the ground. Have you heard of that? Yeah, there are some videos that you should watch on YouTube also. So again, why? Because you have to pay a lot of money to employ people, and not many people are ready to work in remote areas, because a lot of mining happens in Pilbara and those regions, right, where not many people are willing to go. People are willing to go, but not for a long time, because they pay initially to attract talent, because mining used to occur in regions where no one wants to go. What they used to do, they used to pay a lot of money, and they used to do something called FIFO, FIFO, fly in, fly out. That means you live in cities like Melbourne, Sydney, because everyone wants to live in cities, right? With their families, for their kids' education, and so on and so forth. And they also want some entertainment. So if you have to attract good talent, they will not stay in remote area. So you have to take good care of them. So that's why what the companies have done is they used to fly people out of Melbourne, Sydney, Perth, and other big cities, and they would take them for 6 days, and they would drop them back 8 days, so that they can spend time with their families and then go back again. So they had some different rosters, right? 9, 12, 6, 8, like that, based on the contract agreements. And in order to do that, they had to pay enormously huge amounts, big. The paycheck had to be big. As I said, if you have to employ a mining engineer to work, or metallurgist to work, or environmental scientist to work in these areas, they would demand nearly 200,000 rupees as a dollar salary. $200,000 is a lot of money, a lot of money. My students who graduated, I told you that I was the academic member of mining program at Monash. Many students, the first cohort had only 4 students, because they transitioned from third year civil into mining. By the time they finished, the companies have taken them immediately, because they were in huge demand those days. Not many people were willing to relocate to the regional towns and places. They were paid a salary which was more than what my salary was after 20 years of service. You know, Professor Narasimha, that how mining people are taken care. And one is aging population. Australia is aging very quickly, and not many youngsters are kind of willing to. So now then they have to find another way to kind of sustain this particular phase of mining, where they are now going completely autonomous, humanless. So people sit in Perth, people sit in Melbourne, people sit in Sydney, and they operate Nintendo mining, right? Like all remote mining. So again, so Australia's METS capabilities are one of the best in the world. So what Australia has committed to India is that's about critical minerals, but there's about also strategic minerals. So copper is not a critical mineral because copper is widely spread, but copper is a strategic mineral. Anyway, we'll stop now for today here, and we'll come back and then discuss the rest of the stuff tomorrow. Hope I did not bore you, but please chip in your own wisdom, thoughts, everything else. Thank you.
Knowledge and thanks to director minds from local to the global challenges and understanding the root cause and solution to the critical movement problem currently hearing. So I like to this even this.
Thank you, Professor Mohan, for introductory sessions on critical minerals and again scenario reporting. So explaining the global demand for critical minerals. So I think with this today's lecture, we'll meet again tomorrow. As I said in the beginning, tutorials are being organized alternative way. Tomorrow we have it, and therefore tomorrow we will not have it, followed by 14 days. I think you'll see the schedule. Some minor changes might be there in respect to the talk, depending on the speaker and so, and also there is some communication we received saying that classes we may continue here tomorrow, or we may shift to the academic block when doing a block. So we will inform you through email. I have all the email. So, and then also, if you go there, I think very convenient on that. We have to go there. We have that's idea. We have already informed the planning of where you can go and it's arranged based on nominal price similar to students. Yeah. So otherwise, thank you for the day. First day we started little late, but hopefully we got momentum. Thanks to Mohan the way he has explained many things that we don't pay attention usually in the classrooms, which is definitely new learning for me also. Good. Okay, thanks.